Dear all of you, I'm glad to see you. And now we would like to present our work. This work is titled as self-organization conditions for traffic flow on topological bucket with the non-uniform petals. As our colleague, Alexander Tatasov, also works in most automobile and road construction state technical university. So, in a slight introduction. In our paper, we considered a dynamical space system. The system is connected with traffic flow on complex network with topology as booklet. The system contains an arbitrary number of Flowon uh, circuits with uniform point. This point is called the node. The system belongs to the class of Buslaev. The system, this class was developed to create a mathematical model uh, of traffic flow on networks with, with complex structure. And we would like to obtain analytical results for the behavior of this of this flow here. Analytical results, uh, we have about a close to a one dimension lattice. For example, in some our paper, you can see later this one. This some analytical results on the system is similar with our system. Uh, you can see the paper by Streckenberg, Gray and Griffith, Japanese synthesis, uh, Sonnets and missionary, also Russian genetic blends, uh, Beta Middleton and Levin with his dynamical model on rectangular lattice and some another. In this our work, the concept of cluster movement was introduced to model of traffic flow. It's a discrete model, and this model, uh, the rule of movement of particles corresponds to the rule of elementary cellular automata by Stefan Wolfram. This automata has number 240, and we consider the cluster model. Then we consider another system with where particles move according to the rule 184 or 214 with individual and cluster movement rules. And this system was considered in the paper. Uh, mhm. We have some results connected with simple math with two the circumference and one node. And this system has is presented on this figure. You can see two sockets with one common node. And we investigate this system and this paper connected with this result. Okay. Then a system with arbitrary number of circumference and unit node is called as Bouquet. In this paper, results for almost all these models have obtained under the conception that the length of any circuit is the same. Then we investigate the case when the limit distribution has been found for the flat net called an open chain of circuits. Any circumferences of the net space, the almost left, almost right circumference has two nodes with two adjacent contours. Each of the most left and most right contour circumference has one node. And this case was investigated in this case. Then then environment measure has defined signal one open thing. This one. This system called one-dimensional thing. Any circumference of net say for the most left and most right circumference has two nodes with two adjacent contours. And this situation have been presented in this case. This is the picture of the system where common common node divided divided the circumference now not in the center. Now we consider a main circuit system with a unity node. The lengths of the circumference are different. Results are obtained for the same system under the exception that the load of the system is sufficiently large. Namely, it's suppose that the length of the surface traffic is greater than the difference between the length of any conferences and and the cluster located in the center. This is the component. And then a necessary condition has been obtained for the system to result in a state of free movement or from any initial state. A necessary condition uh, for a state of free movement to exist. We discuss how the result for a manual circumference system is really the result when properly obtained for a quick conferences system. And now we would like to description of the system. The system contains n closed line called circumferences. This is a unique common point, and we call it the node. There is a movement segment called a cluster. The velocity of movement is equal to 1 if there are no delays. There may be a delay as a cluster passes through a node. The delay is due to the condition that more than one cluster cannot pass through the node simultaneously. The length of the circumference is equal to Pi. The length of the cluster located in the circumference is equal to L. This system. Cluster is one to several particles. Suppose that with the vector x0, so on, n minus 1, is the system state x times t times the coordinate of leading point of the cluster is equal to each point. So the cluster has to go the distance y minus xy. So the point from point of the cluster is the common node. We say that at t the cluster that occupies the node if this coordinate satisfies this inequality. And to say that cluster I is at the node if its y is equal to 0. The system is so permissible if the state no more than one cluster occupies the node. If at the moment the cluster I begins to build the node, then another cluster occupies the node, then the delay of the cluster begins. And at the same time, more than one cluster comes to the node occupied node, then the computation of the cluster occurs. A computation also occurs if a cluster finishes through the node, and there is more than cluster in the node. What computation resolution rule we use? Computation resolution rule is united with computation cluster for the node. So we use the computation rule is simply, namely the rule is formatted as follows. In the previous competition was won by the cluster 1. Then the present competition is won by cluster I plus H, additional modular n. Additional modular n. Okay. Let's Now, let us say a possible practical interpretation of considered model. Suppose that there are endpoints in the production process. Robots to deliver the material necessary for production to the point from the storage facility. The robot serves point I, travel during T day time, units from point Y to the storage facility and back, taking into account the time of the speed, the cargo from the storage facility. Then, and so on. More than one robot cannot accept the cargo at the same time. Therefore, when the robot receives the cargo, a floor can be performed, but another robot then has come to the storage faculty to receive the cargo. So we investigate the limits of this fraction. It's called average velocity of the cluster of the system uh, and this interval T0 also plus infinity. Uh, if in this interval there is no delay, we say the time T0, the system is a state of free movement. The purpose of the system to result in a state of free movement from any initial state is called of self-organization. In the case of self-organization, the velocity of any cluster is equal to 1. And we investigated this parameter, average velocity. The average velocity is equal to ratio of the total distance traveled by the cluster during the city with the release. We have obtained the following result. Theorem 1. It is this condition for length of the cluster if this inequality is right. It means that the layer in the cluster is greater than the difference between length of any circumferences and the length of the related cluster. Then we have the follow uh, statement. Unit to limit picture is realized, and the period the time is the following. The limit distribution density in one measure does not depend on the initial state, and average velocity of the cluster I does not depend on the initial state, and is computed according to this formula, average velocity. Theorem 2 about sufficient conditions for self-organization. The sufficient condition uh, is this inequality L L0 plus L1 and so on plus N Ln minus 1 less or equal than V. The system results in the state of free movement from any initial state. And theorem 3, necessary condition for a state of free movement exists. Necessary condition for a state of free movement to exist is that for any pair of circumference, the sum Li I plus Lj is not greater than the greatest common division of the length of the circumference, P I and P j. And conclusion. We have investigated the many aspects of the system with unit nodes. For the case of large fluid, although the node is always occupied, the limit distribution of average velocity and its period has been found. Uh, Sufficient conditions for the system to resolve the state of movement from any initial state has been obtained. And a necessary condition for a state of free movement to exist and be obtained. Thank you so much.